Okay guys, so in this video I thought I'd show you how to make a small open source library and the things that you should consider when you're making an open source library. So let's get into it. So first and foremost, let's have a look at this little project of mine. So the other day I had this inclination. I felt, yeah, let's sit down and write a small npm package to solve a problem that I think is fairly nice. Like, it's not the most useful package in the world, but it was something that, to pass the time. So I thought, all right, what could be a nice library that I could have some use case for? Well, I thought, all right, how about we created a library that would allow us to write safe for JavaScript? And how about we borrow the concept of which certain other languages have, which I'm a very big fan of, which is the idea of having operations that could potentially fail or return a result, which can either be a failure or it can also be a successful execution of your method or your function or something of that nature. And so I thought, let's build that in JavaScript just for the fun of it. So the first and foremost thing that you need to consider when you are making yourself an open source library is of course the use case, but this is kind of for learning purposes, so let's just walk through it. So this is my little package called FC results. And I put a little bit of a description here, a library that converts a function that may fail to a function that returns a result. And the most important part when you're doing, like when you're making a npm package or an open source library of some sort, is where you declare your main. Now this property here on your package.json file is where you are going to tell the basically node when you are then resolving your dependencies and people are importing your package, like this is the entry point to your package or your library basically. And then I have just two different scripts here because I don't actually have any runtime dependencies or any production level dependencies. All I actually do have is one single test runner, which is just as my dev dependencies, and that's basically it. And a few keywords that are not all that important. And then of course me as the author, and the MIT license is like fairly standard when you're not looking to go too deep into licensing and stuff of that nature. But anywho, so apart from that, it's very useful to have a README file of some sort where you kind of what I like to do is that I create a description section where I just post basically the first thing is how to install my package, and then I have a short description of what the package is about and like a few of those things, and then of course I have a bunch of, we can actually look at that. Let's actually look at this at the GitHub repo instead, so because store my stuff on GitHub basically. So we have the install, and then we have a few examples of how the library itself works. And as examples are always great, guys. Like if you're making code for other developers, it's very nice to document your API and so forth. And since this is like a fairly small library, I don't have to put all that much work into it. Anywho, so apart from that, you're going to want to have basically an npm ignore. So when you publish something to npm, you are going to basically compress that down into a tarball, and that's going to be sent to the repository. And in the npm ignore, you can imagine that it's very similar to the git ignore. So the git ignore is going to tell Git what directories and files not to include when you're sending files to, say, GitHub. And I don't want to include my node modules because since I have the package.json, I prefer not to include my node modules because they're quite heavy when you have larger projects, and the npm ignore is the same thing. So here I declare what directories and files I don't want to be in the end package that is going to be downloadable for my consumers of the package. So I have this examples directory here that I don't want to be included. I don't want my Git directory to be included. I don't want my node modules to be included because that's going to be installed on the users, like from the user's own stuff. And I don't want my tests to be included because there's no reason for the tests to be in production code, right? So when I publish, these directories are going to be excluded from the publish. So let's just dive into the most important file, which is the index.js file, which is the same file that I declared here. Now you can call it whatever you want, but I just stick with index.js since it's a convention. So I have three modules here, which is called results, OK, and fail. and then I basically just export these 3 library functions. And if we look at my examples here, we can see that I have some code here where we can actually use, like where we actually have usage examples of how to use the code. So basically the way it works is that if I now do something like this, if I do node examples, and let's say we do if else here, and we run that, you can see here that basically what happens is that my result function allows me to create 2 different functions. I have a function that is just going to do an arbitrary operation, and then I have a function that is going to throw an error. And then I wrap my functions in my result higher order function that's going to return a new function. And then as you see here, I call these functions individually. And then I loop over the results, and then in this case I use the if-else interface, or the API part, which is just going to have a function that says is okay. In other words, if this operation was successful, this is going to be an okay, this is going to return true. Otherwise it's just going to be a failure. Now if we have a few other examples here. For example, we can have my result function where I can declare myself if I wanted to create my own function that allows me to return a result of some sort. There's another interface for that where you can do result.ok on a value, and you're going to this is basically a factory method that is going to return an instance of OK. And the fail version is going to make a instance of fail. And what this allows you to do is to do something like this, for example, where you can now grab the constructor property on your result object after calling these safe functions, and then you can just pattern match them or match them against the different instance types if you wanted to do something like that. And yeah, and this is like the switch example is basically the same thing, where you can just instantiate a result and then call the function, and it's going to return either an OK and a failure, and then you can basically just use the constructor property to match which one it is. Or as I showed you earlier, you can use the if-else. And then finally we have something that I call resultify, which allows you to basically declare an object or a class of some sort, and then you can do result.resultify on that class. And what it's going to do is that it's going to return an object that is going to now have all its functions return result functions, basically. So when I call these functions, they are now going to have the same behavior. It's just that the return value is going to be a result instance instead of whatever they used to return previously. So these are just some examples to kind of let whoever wants to play around with the library get a feel for how your code works. So this is a practice that I like, and I highly encourage if you're making your own package, where you kind of like examples are gold when you're making open source projects, guys. It's very, very helpful for someone who's going to try to figure out how to use your library. I mean, I can only speak for myself. I really appreciate it when people have examples. So, apart from the examples, let's actually just look at let's look at the fail. So it's fairly simple stuff. This guy's it's a very small little library that I just built in a few hours, where you have a class of fail, which is going to take in a value and store that value, and then I override the inspect, which allows us to, when, as you saw here earlier, when you log out a failure or an OK, or a failure or an OK, you see that it's actually just giving this nice little printout where it says OK and then parentheses with the value that it contains, and for fail it's the same thing. And as you can see here, I was a little bit opinionated because I didn't want to include the entire error as part of the log output. So if the value that you have stored in the fail is an error, what it's going to do is that the default behavior is that we're going to print out the message of the failure instead of the whole thing. Otherwise, it gets a little bit it's a little bit unreadable if you have the whole stack trace, at least in my opinion. And then finally we have this SOK, which is just always going to return a false, because if you don't want to go through the hassle of setting up a switch and like importing a fail and an OK and so forth, because you know when you get the result back from a method that you're called, you don't really know if you're going to get back a fail or an OK. So this is just to be able to do the if-else. And the OK is basically the exact same thing with even less code. And then finally we have our result function, which is this little guy here. So we basically just take in a function, and then we return another function, and we wrap this entire logic in a try catch. That's all it's going to do. So what we're going to try now is that we're going to return a new OK, and then we're going to call the passed in function with this and whatever arguments are being passed in here. So arguments is a magical keyword that is present in the ES5 standard function. So this function, all the arguments that are being passed into this function these are basically the methods, the arguments to this function here. That's all it is. So you can look that up. It's a magical little keyword that you can use within these old functions. And then, so when we call this function, we basically catch if there's an error, and if there is an error, we simply return that error with the failure. And that's all. That's the entire function. So what now happens is that if we wrap a function in a result, we can always trust that it's not going to throw an error or anything like that. We are always going to get a return value that is going to be either an OK or it's going to be a fail. One of those. And then in order to do resultify, I added a little bit of a helper here. Let's walk through that as well. So I get an object, and then I get the prototype of this object, because the thing with JavaScript objects is that you can use inheritance. So if you have let's say that you have a class that extends another class, I want to be able to resultify or I want to be able to walk the entire inheritance chain and simply override all of those functions and make them into result functions instead. So I get the prototype of the object, and then I get the keys of the prototype. And the reason why I want to get the keys is because if there are no keys on the prototype, that means that the user passed in a simple object. In other words, it's just an object with possibly a few methods. There's no prototype chain, there's no inheritance or anything like that. And if that is the case, I just want to check if there are any keys on the prototype object, because if there are none, then we will simply grab the keys of the object, and then we're going to just run the replace functions method, the function, and return. But otherwise, we're going to go and do a little bit of a while loop. So while there is a prototype object, in other words, as long as there is a parent class or a superclass of whatever's the object that's being passed in, we're going to get the property names of the prototype and get those keys. We're going to replace the function, or replace all of those keys on this object basically, and then we're going to grab the prototype, and yeah, that's basically it. So what now happens is that we are getting a new prototype, and we get the keys of that prototype and replace them on the object, and then basically we grab the next prototype. We get the prototype of the prototype, if you will. So we can recursively, if you think about it, walk up the inheritance chain. So, and then finally we just return the object. And then down here we have a few convenience functions like the fail and the OK, which all it's going to do is that it's going to allow us to instantiate an OK with the value that we pass in, and a fail if we wanted to do that. And let's actually just look at the replace functions call as well. So we take in the keys and the object that we want to overwrite, and then we loop over all the keys, and then we grab the property of the key, and and this could be a function. I mean, an object can contain many things. It could be a function, it could be something else, right? And then we simply type check it, and we check if the function is, or the thing that could be a function, if it is a function, and the key that we are looking at, in other words, the name of the property that we're looking at, is not constructor, because we don't want to overwrite the constructor behavior. We only want to overwrite the methods on the object itself, not the constructor. And then finally we simply overwrite it. That's it. We just say that, okay, this property name, just make a result and wrap this function inside of, or add that to create the result function of this function. And that's the way that we can now basically convert an entire object with all of the internal methods and all the super methods, or the superclass methods, into an object that only holds result methods. So yeah, finally we'll just look at the unit tests, because we want to test this stuff, because odds are that if, let's say that this package was a little bit more useful and maybe it was like something that started getting some traction or whatever, then we want to make sure that we already have a testing strategy for it, because we're going to get issues and other stuff of that nature. So it's important to already think about testing when you're developing your libraries. So these are some basic tests for the fail case, which they're fairly straightforward, so I don't have to go all that much into them. They basically just check that the inspect is working correctly and that, that this is okay is returning false. Like, these are fairly trivial things, and the same thing is with the okay one. The more interesting one is the result one, where the first thing is that we check that we have a module. It's just to do a sanity check. And then we simply check that, okay, so if I create this little sum function here, I wrap that in a result, then I expect that if the instance that I should get back is basically an okay, and that's it. So that's the entire test. I just make sure that if the function call that I do after wrapping my function in a result is going to return an instance of okay. That's it. And the same thing goes here for basically for doing the failure case. I can actually see here that we missed something. Let's actually add that in here. Let's actually do this. Let's do that. Let's remove that, and let's do this instead. And let's do that instead. And the test. Let's do that. Cool. So that's now working. So we made our test a little bit better. And then we have like another test here. Returns a fail for a function that makes an undefined reference, which is basically this function here. So we have an object and we do object.foo, but in our little result function which we created here, we are not passing anything in. So this is going to throw a cannot read property foo of undefined error, which is, as we saw earlier, the tests are passing. So this is all working. And then returns a fail for a function that calls a missing function. And basically, yeah, so I have this number and I do number.toCookies, and then I pass in a 1, but hey, 1 doesn't have a toCookies method as of right now anyway, and so that's going to cause another error and so forth. And then we have another section of tests here for resultify, where basically all we're doing is that we're testing that, all right, that you can actually resultify all the methods that are internal to a plain object. And then we have a few methods that's going to make sure that we actually overwrite all of the methods of the object. And so that this is the one thing that it's doing that may or may not be a good idea. So you're going to override, like it's going to mutate the original object as well as create a new return that object when you do resultify. We might want to change this in the future so that it doesn't mutate the original object, but since I threw this together in a few hours, I didn't really have time or an interest in fixing that. Anywho, returns a class instance with result method, so we make sure that because there's a difference in semantics between a class and a plain old object, so we make sure that the class version is working as well. Does not break this inheritance chain on a class instance. So if we have a foo and we actually instantiate that with a value and we actually reference that value from our foo method, we expect resultify is still going to respect the chain of this. In other words, so that if you are using this keyword on the foo instance, you want that to not be broken by using our resultify call here, or like that mutation. It does not break this inheritance chains for a subclass, which is the same type of idea where, okay, so we have a foo class and then we have a bar class that extends foo, and then basically we make sure that we can run all of both the foo method and the bar method, since the foo method is a method on foo, but bar should also, since it's extending, foo should also have access to the properties that is on the foo instance or the foo class. Does not break this inheritance chains on a function. It's the same idea here. Instead of using a class, we're just using a constructor, like the old style of doing constructors or constructor function. And then finally we have these two helper methods, and that's basically all there is to it. So this is like a very brief walkthrough through a very small package that I threw together more for fun and like just my own personal enjoyment than it being all that useful. But if I wanted to now to say, let's say that I wanted to publish this. Let's say that because we actually changed the unit test, let's actually bump our semver by 1. Let's do that. And then let's do this get status, because we did actually change some stuff. Well, actually, let's do the diff over here. So let's see here. Yeah, we bumped the version, which is awesome, and we added a little bit more specificity to our test. So let's commit all of that. Updated unit test. Let's do that. And then let's do git sync, which is going to do all the good stuff. So now we're saving, and now we have a new updated version on our repository here. Let's see here at the top here. Now you see that, hey, it's actually 17 seconds ago, so we have a few files that have been updated. But now, even though it's not all that necessary, I'm going to also do this. 1.0.1. I'm going to set a tag. And let's do 1.0.1 git push origin. Sorry about that. And there we are. So now we have a new tag. And the reason why we want to have a new tag is because we want to be able to go to this section here, and we want to be able to reference that tag so that in the future, if we have multiple versions, we allow people to actually roll back to a previous version if that is necessary. I can even see here that I actually forgot to push the original version. That doesn't really matter. And then finally, now that we have made our awesome update, I'm just going to do this. Since we already excluded the tests from our package, it doesn't really matter all that much, but let's do that anyway. So I'm going to log into npm. Let's do that. And let's do that. And then finally we are going to do npm publish. And hopefully everything works. And ta-da, there we are. So now we have officially published to npm. So let's go and have a look at, because in order for you to publish to npm, you of course need to have an account set up and all that good stuff. Let's look at the package. And as we can see now, FC result is now officially at 1.01. A few seconds ago it was updated. So yeah, guys, that is basically how you create a small scale open source library, and a few tips and tricks on like what you can think about before you start making your own npm packages. I hope you have a great day.